In today's lesson, we will discuss some important properties of light. Light is a common phenomenon, but if I ask you, what is light? How many of you will be able to give me a satisfactory answer? Or an answer that is satisfactory to you? What is light? Well, the present day understanding of light is that it is made up of particles called photons which have wavelength and frequency. Now, can particles have wavelength and frequencies? Well, that is where quantum physics comes in. Well, everything is actually dual in nature. You and me are particles, but also behaves like waves. It becomes more apparent when you look at particles like photons. Well, the energy E of a photon is directly proportional to its frequency, and it is given by the equation E equal to hf, where h is a constant called Planck's constant and f is the frequency. Planck's constant has a value given by this, which is 4.136 times 10 to the negative 5 electron volt second. And 1 electron volt, I think I talked to you about that in one of the early lessons. 1 electron volt is the energy acquired by an electron when it is accelerated by using a potential difference of 1 volt. And it is equivalent to 1.602 times 10 to the negative 19 joules. A very small amount of energy. Well, one of the most important properties of light is that light can reflect. Light can be reflected. Now, that's a common phenomenon all of us understands. Here I have produced a beam of light that is on the table, and I have light rays that make up these beams. I have about 5 light rays here. If I allow these light rays to fall on a plane mirror, you can see I have kept a plane mirror there, you can see how the light is reflected. Now here, this is an incident ray which falls on the mirror, and that is its reflected ray. So an incident ray and a reflected ray. The property of reflection is an important property of light. So the ray of light that strikes the reflecting surface is the incident ray, and the ray that leaves that surface is the reflected ray. If you now draw a perpendicular to the surface at the point of incidence, we call that the normal. The angle between the incident ray and the normal is the angle of incidence, and the angle between the normal and the reflected ray is the angle of reflection. Now, reflected light obeys the laws of reflection, and the most important law is that the angle of incidence is equal to the angle of reflection. Well, images on a plane mirror, you know that when you look into a plane mirror you see your image, is that right? Well, everybody is familiar with that. Now, the image produced by a plane mirror is actually due to reflection of light. And one of the properties of light that they did not discuss is that light travels in straight lines. Now, at least that is the perception we have, and that creates a lot of illusion. Light is a very deceiving phenomenon actually. It can actually create a lot of illusions. Now, this diagram shows you how an image is formed. Now, you can see an object is kept in front of a plane mirror. An incident ray on the mirror gets reflected according to the law of reflection. Now, if you look from here, this ray will not appear to be coming from here. It will appear to be coming from somewhere behind the mirror. You know why? Because light travels in straight lines. So look at the illusion it creates. It gives you the illusion that this light ray is coming from there. Therefore, you see the image of this point A at the point E. Similarly, a ray striking the mirror here gets reflected that way. And if you look from here, that ray will appear to be coming from there. That means if you can construct the images of all points describing this object, that will give rise to the image. And now some of the characteristics of the image produced is upright. This is the object, the image is upright. Now the image is the same size as that of the object. That requires no explanation. And the image distance, the distance of the image from the mirror, we call it d sub I, is the same as the distance of the object from the mirror, that is do. So di equal to do, and these are some of the important properties of images. Now, another and important one is the image is a virtual image. It really doesn't exist there. It's an illusion created by this rectilinear propagation of light. Now, if I now look at my image, can I catch it? It's simply not there. It's an illusion. So, it's a virtual image because it is not formed by the actual intersection of the rays. If an image is formed by the actual intersection of reflected rays, then it can be caught on a screen. Then it is a real image. This is not a real image. How about curved mirrors? Have you seen curved mirrors? Mirrors that are curved? Well, they are very common around. If you go sometimes in a hotel, they have a curved mirror which will make it easy for you to shave. It will make it bigger. Your face will look bigger. Now, the laws of reflection are also obeyed on curved mirror. Depending on the curvature of the reflecting surface, there are two types of mirrors. Now, one type of mirror is a concave mirror, and the other is a convex mirror. Now, if you notice a concave mirror, the reflecting surface is caved in. On the other hand, a convex mirror, the reflecting surface is caved out. So that's a concave mirror, and this is a convex mirror. Let's now talk about some of the important features of these curved mirrors. The center of curvature. You see, if you take a curved mirror, all right, if you take a basketball and cut one part of it, that will be a curved mirror. In other words, a curved mirror can be considered to be part of a sphere. The center of such a sphere is actually called the center of curvature of the mirror. So, center of curvature is the center of that sphere of which the mirror is actually a part. Now, if you draw a line passing through the center of curvature and touching the mirror at its geometric center, that axis is called the principal axis. Now, the distance from the center of curvature to the center of the mirror is called the radius of curvature, and we're going to represent that by the uppercase R. Now, if you allow a set of parallel light rays, after they hit the mirror, they will reflect, and the reflected rays will actually pass through a point on the principal axis. And that point is called the principal focus, and we will represent that by the letter F. And if you measure the distance from the principal focus to the mirror, it is called the focal length of the mirror. A mirror is characterized by its focal length. You can see I am actually going fairly fast with these. They're very simple ideas. Now, the mirror formula. If an object is placed in front of a mirror at a distance u from the mirror, so u stands for the object distance, and if f is the focal length, lowercase f, an image will be formed at a distance v from the mirror. So you must get used to u is the object distance, the distance of the object from the mirror. V is the image distance, the distance of the image from the mirror, and f is its focal length. Then 1 over f equal to 1 over u plus 1 over v is the mirror formula. In other words, if you can measure u and v, you can calculate the focal length of the mirror. So depending on the position of the object, the image may be bigger, smaller, or the same size as that of the object. You can actually create different types of images on a curved mirror. Whereas in a plane mirror, you can only create one type of an image, which is a virtual image. For using a curved mirror, you can actually create different types of images. All right. If HO is the height of the object and HI is the height of the image, then the magnification produced by the mirror can be written as M equal to HI divided by HO, the height of the image divided by the height of the object. And that will be the same as V divided by U, the image distance divided by the object distance. Well, in the case of a plane mirror, this magnification is 1 because the size of the image and the size of the object are the same. But in curved mirrors, you can create different types of images. You can create bigger images than the object and smaller images than the object. In such a case, magnification is a relevant quantity. Let's see how we can locate images in curved mirrors.